So I think we left off at ST. Alright, because I've had a lot of data go missing as well, and I can't get onto my backups at the moment. Next week, hopefully. And I think we left off at ST and elementary particles, up quark, down quark, charm quark, strange quark, top quark, bottom quark, leptons, which were electron, muon, neutrinos, muon, neutrinos, and tau neutrinos, electrons, muons, and tau, and then bosons, which were photons, gluons, Z weak force and W weak force. And I think I was trying to tell you that Z's a reference point and W's a plus or a minus around Z. And then I went and scrolled down the page well too fast. Now I've really ballsed it up. Oh dear. Right then. So, and then I think I was talking about the Higgs boson and the Large Hadron Collider underneath Italy, Switzerland and France. It's 8 kilometers in diameter. I think. Oh, it's a big thing, isn't it? You know what I mean? Anyway, they've got some theories about they're going to see the starts of the universe, and well, my theories are, and just this spells it out for you. So we're going to have particles coming towards each other. See? Coming towards each other. Right. And then we're going to have a collision, aren't we? Yeah. Right. And each one of these particles are going to be travelling at c, aren't they? Yeah. Or the speed of light. Okay. So you've got a finger in that way and a finger in that way, and when they collide, you've got the speed of impact of 2 times the speed of light, haven't you? Relatively speaking. Relatively speaking. Right, so I theorise, right, that you're going to have an explosion. No, I theorise that you're going to have bits ejecting off of that, yeah, as these small little particles fragment into tiny little bits and smash to pieces, yeah. And I estimate the speed of ejaculation, is going to be, well, it's going to be between the speed of between c and 2c. That's what speed that's going to be. Alright, now then, this is where it starts getting interesting, because now I've got possibility of having something ejecting at 2c. Pardon me. Right, so I'll call that ejector there, right, I'll call that C question mark. Alright, now then, I'm going to have 2 of those explosions happening very close to each other. C question mark. C question mark. So now I've got a C question mark going that way and a C question mark going that way, and now they're going to collide. Alright, inside my Stenge collider. Alright. And then we're going to have a collision there. Alright, that's the ejector of this. Alright, and then another one of those down here, another one ejecting that way, and then another, and then it's sort of like a a big explosion there, but that's that there, like, yeah. Alright. And now we're going to have an ejector. We're going to have ejections from that explosion, from that collision, of between C and 4C. So it's between C and 4C. Okay? I'm not joking, this has really happened. Alright? C and 4C. And I'm going to call that, right? I'm going to call that question mark C. Now you see I called that one C question mark, and I've called this one question mark C. You see that? Alright, yes. It's good, isn't it? Right then. Now, after that, I get this here. I'm going to speed up this process a bit, because I think the clever ones of you will be already guessing what I'm going to write down next. Obviously the not so intuitive ones are going to be needing to see the drawing. So there on this one here we've got question mark C and question mark C colliding, right? And we've got the ejector coming out of question mark C and question mark C collision, and the speed can be between C and 8C. I'm going to call that question mark CA. Alright, now as I'm doing these calculations, and my calculations are vast, by the way, I came up with these calculations and these theories before the Hadron Collider was even thought of, when there was this one in America, I can't remember what it's called now, particle accelerator, and it's X-ray something, called it researches X-rays. Anyway, I came up with this then because, well, what they were finding was when they were colliding these things together, right, and they were having collisions, and they were measuring the things that were coming off of it, right, and you know they were developing or artificially making heavy elements and what have you by bombarding and doing all these other things, like, yeah, gaining mass on heavy elements and making heavier and heavier elements, making element 115 for small amounts of time. And well, it occurred to me that when they were smashing these things to bits, alright, and then grafting the remnants of these bits onto other elements and making new elements, alright, I'd grasped the theory that, well, they were smashing them together and bits were flying off. It was an amazing theory. Right. And when they said that these things were colliding, and one was going at the speed of light and another one was going at the speed of light, or close to the speed of light, that meant the closing speed was 2 times the speed of light. And then that theory came to me that, well, the possibility is there that some of the pieces could now be going faster than the speed of light, because the amount of energy that you create in a 2C explosion, the possibility of getting something going faster than the speed of light coming off of it is there. Definitely there. So that was faster than the speed of light. And that was 14, 15 years ago, just before they announced the Hadron Collider. That's when I came up with that one. And, well, I think CERN's going to prove that. I think they're going to do experiments in CERN which is going to prove what I'm just saying now.